So in our previous part of our notes, we just reviewed some algebra rules that deal with powers. We're going to use that as we start talking about a power function. So let's just quickly look at the definition. This is any sort of function that can eventually be written in this form. A, which is a number, times x to the p power. The only restrictions on a and p is that they cannot be 0. Okay, they're going to be a number, they're going to be some sort of a constant. They just can't be 0. So they can be nice integers, they can be fractions, they can be messier decimals, but it just can't be 0. Okay, we would call p the power. A is the constant of variation or the constant of proportion. And I just want you to note that our textbook does use different letters for this. And I've chosen these letters because I think they'll connect better to some of the things we looked at earlier in the school year. And the book letters might confuse us a little bit because we use them for different things. So let's just try to rework something so we can find the power in that constant of variation. We just did this in our algebra review. We can take the 9x, take the individual square roots. That means that the square root of 9 is 3, and x can now be raised to the power of 1/2. And that means that our power is 1/2 and our constant is 3. So sometimes this can be pretty simple. You're going to have some questions from your textbook that are a little bit more challenging, and my little hints for that is just make sure you're aware of in the instructions what they're saying is a constant all the time. Okay, we can also look at something called a monomial function. It's got the same general form as a power function, but there are some restrictions here. Okay, a is a constant, and it can be any number now, so it could be 0. Okay, and then p has to be a non-negative integer, so it's got to be an integer, but it could be 0, 1, 2, 3, 4, etc. So just something else for us to kind of think about. A lot of times monomials and power functions, they can be the same thing, but there are some slight differences where there are some exceptions. A rule could be a power function, not a monomial, or vice versa. So let's just kind of look at some common ones. This is just x to the first. Okay, so that would be both a power function and a monomial. It fits both of their characteristics. Okay, this would be x squared. So I don't know if you guys want to kind of label this by the picture just so that we're aware of some of these things. Okay, this would be x cubed. This is just x to the 0, so technically not a power function because a power cannot be 0, but this would be considered a monomial. Okay, and then we get into some other things. This would be x to the 1/2, square root of x. Okay, whoops, let me go back. This would be a power function, but not a monomial. A monomial, the powers have to be positive or non-negative integers. Okay, here's our cube root of x, x to the 1/3. Okay, this is 1 over x, x to the negative 1. So again, this is a power function, but not a monomial. And this is 1 over x squared, or x to the negative 2. So those are kind of our main ones. Just want to show you a couple things to be aware of when it comes to power functions and maybe even monomials. So I just want to show you a couple pictures here on Sketchpad. If we just look at the right side of a graph, some things you're probably aware of, but as that power increases, the right side of the graph generally doesn't change a whole lot unless the coefficient becomes negative. But what you notice is that it just kind of becomes a little steeper, grows a little faster every time that power goes up by 1. Okay, and we could look at both right and left side. We kind of know this already too, but just kind of that oscillating idea. If the power is even, both sides are going to go up. If the coefficient's negative, they both go down. But then when that power is odd, they kind of alternate. One side's going up and one side's going down. So that's something to be aware of. And what's kind of interesting is we can do the same thing with roots. So like our square root, nothing exists on the left side, but we can see that a cube root, whoops, if I was dragging it the right way, that would help. Okay, there we go, a cube root. It's doing something on the right and the left side. Just kind of has a rotation to get that left side. Then a fourth root is kind of like the square root. There's your fifth root, like a cube root. And now it's not going to graph it as well because it's getting very, very close to a vertical line right there, so it's a little harder for it to graph. But just some kind of interesting things for you to note there. Big thing for this chunk of notes, just make sure you kind of know the slight differences between a power function and a monomial. But we do see them all the time. So I'll stop there, see if you have any questions.